Okay, here we have chapter 4, page 124. We're going to do number 50. Number 50 is a steel I-beam, and it tells us there's a weight of 8 kilonewtons. Now, the weight is 8 kilonewtons. That means that it's not just going to be 8 newtons because it has the kilo preference, so really the weight is 8,000 newtons pointing down. And it's being held up by the tension of these wires, which are at 70 degrees, both of them. And they want us to know what the tension in the wire is. Because this is moving at a constant velocity, we know that the acceleration in the x and y direction is going to be 0. That means the net force in the x is 0. That means the net force in the y is 0, which means this is all going to be equilibrium. So the trick to finding this out comes down to the fact that these two pieces here are symmetrical. Because these two tensions are symmetrical, their actual tension force has to be the same. And because they're the same angles, that means their x components have to equal each other. So if we draw our x components here, have to equal each other, and their y components have to equal each other. So we'll call this Ty. Tension in the y, tension in the y, tension in the x, tension in the x. So these are going to represent the x and y component. Now, since we have the net force acting in the y equal to 0, let's magnify this one. That means that the tension in the y plus the tension in the y minus the 8,000 newtons have to equal 0. That means we have 8,000 newtons. If we move the 8,000 newtons, is equal to 2 Ty, which means the tension in the y is going to simply equal 4,000 newtons. Now, we found the y component, but that doesn't help us because we're trying to find the x component. But at the same time, we know that if we have a triangle where at a 70-degree triangle, and we know that the y component of this, or the height of this, is 4,000 newtons, then we could be able to solve for the actual 10 using our trig. We know that, for example, we know the opposite, we know the angle, and we're trying to find the hypotenuse. So we know the opposite, and we're trying to find the hypotenuse, so sine makes the best sense. So we can say that sine of 70 degrees is equal to the opposite, which is 4,000 newtons divided by the tension, which means T sine of 70 is equal to 4,000. So T is equal to 4,000 newtons, forgot a 0, divided by sine of 70 degrees, which ends up giving us T is therefore going to be equal to about 6,222 newtons. So that ends up being our answer. So our total work is here. Now, this is the shortcut way. In the next video, we'll be doing it the long way, which is a little bit more using systems of equations that I'm sure you guys will love. Oh, made a small mistake. 4,000 divided by sine of 70 is not 6,222. 4,000 divided by sine of 70 is 4,256 newtons. I'm not sure where I got that other number from, but this is your full answer.